Hello everyone, welcome back to another TouchDesigner tutorial. It's UV here again. This time I want to introduce you with the ParticleV. It's a particle system that I've been developing for the last maybe half a year. Slowly I packed many functionalities and tricks and stuff. Um, and recently I just pack it into one component, which obviously might develop more. So yeah, today I want to show you how this system works and all the functionalities that it has. I will try my best to cover everything, uh, um, the basics, let's say. And there you will get the project file with like 5 examples. And Yeah, in these examples I tried to take the system to like different aspect of the system. So I will walk through all the examples also. But let's start with the basics. So when you will open the project file, you will have like 6 components. This one, it's the viewer. It's what you're seeing here. And you can change by clicking on those buttons over here through all the examples that I will be showing you today. So you can have a quick look at them right now. um, so as you can see, there's like a lot of variations you can make and really crazy stuff. So let's dive into the basic one, so I could show you how the component works. So when I click on the basics, I can open up um, the basics project, and as you can see here, we have the particle V component, and obviously it has like all the parameters. So it has the simulation tab, which basically you can control everything that is happening in the simulation itself. um, and the render tab, which you can control the render, which is inside the component. So let's yeah, and so like what's going on over here, all of those tops are basically referenced inside the component. So for example, the feedback, init type, all of those are like tops for like you know, initializing and coloring and sizing. And we have also attractors. So this is how I built it. So you can keep them like outside and just change it, and keep the reference over here the same. All right. So um, the core of this particle system um, is basically, it's a bunch of points, right? Um, or particles that has like a collision detection algorithm inside with like a GLSL, which basically calculates the distance between each particle to the other particles. So it's a pretty heavy calculations, but yeah, with a good GPU, you can get like to let's say this amount of particles, maybe more. So it's really depends on your system. but it works pretty fast. So there's like the repulsion and you see the repulse force and attract force, which applies to each particle based on the distance of the of the particle to the other particles. Let me just for a second not render the attractors. Um, and and let's turn the no, sorry. Yeah, let's turn this off. Yeah. So you could see it better. I'm doing it fast right now, but I will show you everything. So and let's also go inside the render by clicking over here, and I want the camera to be in the face of the light so we can see everything nice and clean, and we can also um, turn a bit off the light. All right, so maybe okay. So in the simulation tab we have the repulse and attract force. So as you can see, when the repulse force is high, so they're repulsing each other, and when they attract, they basically attract each other. And the ratio between the repulse force and attract force, that's what makes them basically have this spherical shape. And obviously I'm applying also some noise to the movement, so you can see a bit of the movement, but um, as you can see, they're like kind of building a structure where they're trying to avoid each other. All right. um, no matter what the force is it. So that's the core of the system, and with more manipulation added to this, not simple, but this core forces, we are building all the other stuff. So let's move on. Beside of this collision, we have also a metric type force. So originally I wanted to build like the particle life algorithm, which is basically an algorithm which you have like many types of particles in your system, and they're interacting with each other based on their type. So for example, type number 1 is repulsing type number 3, and type number 2 is repulsing type number 1. And then it's like, it's creating this kind of like um, system of rules based on the type of the particle. So I've implemented it with like here in this system with 4 types of particles. And it goes like this. You can click on the apply metric force, and you have the initial type. As you can see, it's like, you see they're like kind of getting moving in clusters, but we don't see the difference between the types because I will show you in a minute. So the initial type, it's just a noise texture that you can feed in, or if you don't feed in, it's like it's gonna be like the default that's inside. But you can play around with like the initial types, um, but just keep the noise between 0 and 1. Um, all right, so this is the null force matrix, which is basically a table over here. So currently it's this table, and this is basically the rules of which the particles will move. I will get into it in a second. And this is the amount of force. So if I put it at 0, they won't attract, and at 1 they're starting to attract, and the distance in which they will be attracted. So as you can see, when you raise it, it's yeah, it's like kind of like a threshold. And the color type, which is a texture over here, let me also open the, yeah, which is a texture over here, with 4 colors and the layout, and then I'm referencing it over here. But why we don't see those colors? Because in the render, I have another color, which is like the particle color, and it's, as you can see, it overrides the type color. So you can delete it like this, and then you will see like the type. So if I reset by clicking 1, because I have a keyboard in here, it is referenced in the reset pulse. So you can see the particles starting to attract each other based on the type. So currently each type of particles are attracted to their same type. So this is why we have those kind of like clusters. And another way to color them, it's like to keep the color over here, but multiply with the color type. So we will have something like this, because the color texture, which is over here, it's currently just a noise. And of course we have the particle size. So it's also a texture over here, in which currently it's like a constant. So if I put the noise over here, you can see the results, and you can play around, and then they are like kind of randomly scaled. All right. So yeah, about the force matrix, or this table. So how it works, it's we have like a 4x4 matrix, and basically each cell, it's the force of which type of particles are attracted or repulsing each other. So currently it's like diagonal of 1 1 1 1. So 0 attracting 0, it's 1. Or if I put it -1, they will repulse each other, because the type is 1, like the type 0, it's like the green one, as you can see. So you see they repulse each other, and yeah, so now they're all like 1 and 1 is attracted, and so on. So you can play around and just keep it like symmetrical. So if you go, okay, I want particles 0 to be attracted to particles 1. So it's like the green ones are attracted to the black one, or like grayish one. But you need to put it here -1. So it's going to be like symmetrical. And you can see slowly it's like if you add more rules, so you will get like more interesting results. So let's try another one. Let's reduce the amount of particle 2 is attracted to himself, and let's say particle 2 and 3 are attracted to each other, but like way stronger. Let's say something like this. Yeah. So you can start to see that they are like doing their own, and of course you can increase the amount. So yeah, I will start moving, and obviously I will recommend you to just play around with this matrix and start like getting different results. All right, I think this is enough for this section. So yeah, you have a lot of playing around with it. Oh, wait a minute, let me show you one more thing. Is you can make it also 2D, which gives it like a very nice look, like, you know, into dimension. Um, and then you can actually see um, the forces a bit more. Let's reduce the size of them here in the render, the particle uniform scale. So you can start seeing like more of the forces. Let's maybe the collision. Yeah. Oh, yeah. This is what I wanted. They're starting to like kind of attack each other or whatever. With just like simple rules. Um, cool. So here in the general setting, you have the number of particles, which basically I'm referencing from this chop here. So I have like a count, and then I'm like, oops, sorry, I'm squaring it and referencing it. I have the speed of the simulation, so don't exaggerate, because you see it's like it can get pretty messy, which is also nice. Yeah, if you like this look. Um, and the feedback, we will talk about it later. All right, so this is the metric type force. Let's turn it off for now, and let's also get rid of the multiply with color type. So will have them just like based on this color texture. Um, and let's increase the size maybe a bit, make it 3D again. Great. So next we have the attractors, but before the attractors, let's talk about the external force. So the external force, it's like a texture that comes from this guy over here, but basically it's based on a noise, which is here. And you can increase the external force amount. Also, we can change here the particles to boxes and make them a bit like, longer, something like this. Maybe change the size not to noise, so I will turn off the noise, so you can see they're like also moving to the direction of the movement, which is nice. So about the external force, you can increase it here, and to create the force, what I did is basically from within the particle system, let's say ParticleV component, we have the force map. All right, so we can get it from here, and also I can dock it if you don't want to see it for some reason, but this is important because to apply a noise force, like a force based on a noise, we have to connect the our position to the noise coordinate map. So it's very important, very important. And to connect for the first input, just to get the right resolution, and here just select the noise, and then I have a null here, I call it external false, and I'm referencing it here, which basically it's taking it from inside the system here. So pretty big system, okay. And adding the noise inside the simulation. So you can play with this noise here. Let's color it. Change the period or harmonics and so on. Obviously you can change also the amplitude here if you want, and type and animate it and do whatever you want with it. Yeah, so this is the external force, which basically add more dynamic to the system, because without it it's like a bit just like a sphere. Cool. So let's talk about the the attractors. So attractors, okay. So here we have the attractors. So first, to see the attractors, we need to go to the render tab and select render attractors, and you can render them as spheres or circles, but obviously you can go to the render network and you can change here the attractor geo and basically change it to whatever you want. And also, basically you can turn on off the render and take all the data that you need from here. So you have the position, you have the color, the rotate to vector for the direction, the size, um, and the attractor position, color, and scale. So yeah, if you don't want to render with the render, and don't be afraid to render it yourself. So for the attractors, we need to toggle the render attractors, and we need like position, scale, and color. So yeah, for that we have those textures. So basically it's a noise currently. It's just points in 3D. And I chose here a color based, like I just took the resolution here from the noise and choose a color. Um, and yeah, this is the position, and also with the scale, it's like now you can have like a different scale. So to make them actually attract or repulse, you need to activate the attraction force, and you can start see that they will basically yeah, attract. And here you can change the general scale of the all the attractors, um, and here the force amount. So if you make it very big, you can start see it. Yeah. One more thing you can maybe let's make them circles, and I think less, yeah, less like external force. You can see the actual attraction. You can also have the attractor color effect, which will color the particles based on the color of the attractors. So you can play with the threshold, the soften and close, which basically how close they are, and far. So yeah, if you don't want them to be dark like this, you can raise a bit to the far. um, and yeah, just play around. So if you have also like yeah, like different colors, you can see the effect much better. um, Maybe, yeah, I think like a lot of playing with the parameters, that's something you need to experience with the system. So when I raise the attract force, I think you can see much more of the attractors effect. Um, so you can also have uh, the attractors size effect, which is basically the same but with the size. So currently, I think particles that are being attracted are getting bigger, as you can see, which is also nice. And you can also flip it, like something like this. So they're getting smaller when they attracted. Yeah. So this is the uh, attractors. So obviously you have a lot of playing around just with this, um, and yeah. So I think this is like the basics. Let's see if I missed something in the render. Okay, I believe I covered everything. Obviously, it can be also um, 2D, but now um, I might not need to change stuff. So let's change the here the attractors to be just RG. Let's make less attractors. Let's say 10. Um, let's make them purple and a bit smaller. Oops, sorry. And the color effect I don't want, and yeah. So you can see it works also with like 2D, which is very nice, and you can make them circles. Something like this. So yeah, let's go to the sorry, let me drink a bit of water. All right. So let's go to the second example, which basically covers what I wanted to show you. So here what I have is a bunch of attractors in 2D, and it's also I'm doing the matrix type force. So I have 4 types with colors, and yeah, I think this is like a very simple example, but very beautiful in my opinion. You can obviously play around with the size here. um yeah, and have have the also the size attractor size effect. Um, so if the particles are being attracted, they're getting bigger, um, or the opposite. Um, Something like this. You can, um, yeah, you can color the attractors to have a bit of like different, you know, something crazy like this. Um, so yeah, so they basically kind of like having like a green light where the attractors are being um, you know, moving to. So yeah, it's a very basic example, but let's move on to some more exciting stuff. The clusters, you need to reset when you change the simulations. Just press 1 to reset. Right. So the clusters. So one section that I didn't covered yet is this. In the general settings, you have this feedback, and we are basically referencing a feedback here, null. So I'm taking the output of the here it's feedback. So I'm taking it. I'm doing a bunch of stuff here, right? This is not supposed to be here. So I'm doing a bunch of stuff here, and I have a null here that I'm referencing back to the system. So it's kind of the same as the external force, but not really, because here we're doing like a bunch of other stuff. So basically, you can put here anything that you want between like the feedback and to feedback. But I mean, any top that you want, kind of that manipulates pixels, but you won't get any results. Like, it's like you need to put some stuff that will actually do something nice. So, for example, pixelate. What a pixelate is doing, it's basically creating those clusters. So it's very similar to the metric forces with like a different group of particles, but here we can create like much more type of groups, as you can see. So if I increase the dry mix, you can see they're becoming like more and more circles, something like more strong forces. Um, and you can obviously play around with the amount of clusters. Um, so yeah, and you see the colors are like kind of mixed, but this is in purpose, because I have another pixelate over here which has the same it's like the same, it's referenced here with the horizontal pixel size and vertical pixel size over here. So this is like a texture of the color which I reference here um, in the particle color. And if I want the clusters to be fully one color each, so it's like it should be one here, but you can also have it like a bit randomly, kind of. It's not randomly, but something like this, which is also very cool in my opinion. So this is like the clusters. um, Obviously you can do the same with the size, so the same pixelate is here. Let me color it also in blue. So each cluster will have its own size, um, which is also really cool. Obviously you can still apply the metric force if you want, which will, you see, will make something like this, which is kind of cool, you know, because now we kind of have like more type of um, of particles. um, yeah, so this is like cluster example. You can obviously play around with it and do other stuff and different looks. You can, you know, um, change to boxes and so on, and play around. Let's go into the brain example. So let's jump to the brain. So um, here we are basically doing the same with the feedback over here, but not only the pixelate, also the blur. So the blur, without the blur, it's like this, you know, with like kind of like clustering, which is also very cool. But with the blur, we can get kind of like snaky vibe or brainy vibe, and obviously it depends with which method you're creating. So with the horizontal, it will be something like this. Let me increase the whoops. Yeah, it will be something like this. Obviously the size here is also changing, so yeah, you don't really see what's going on, but like if I um, in the render I delete the size for 1 second, so you can see it better. I think the size is also manipulated by the attractors. Yeah, but let me go back. So the vertical and horizontal, and also you can do like horizontal and vertical, and extend also. Repeat will basically repeat it, so the snake will be fully connected, and with the hold it will have like you know, here, edges that are not connected, which is also very cool. um the filter size also changing stuff. So yeah, play around with it also, and obviously the pixelate. Cool. So let's return back. It was boxes or spheres, I don't remember. Oh, also here I think I'm rotating it. So if you take like a point transform and I want to rotate through the y-axis, so it's like rotating, which is also nice. All right. What else am I doing here is okay, the color is just like a noise over here. Let's keep it clean right now. Oh, and the size. So the size is also like uh, noise that it's like animated here, and the pixelate of the size is also like the same size of the pixelate here. So it's correlates each other. Um, correlates. I don't know if this is the word, but they are like matching. So it's yeah. So like without it, it's yeah. All right. So yeah, a lot of playing around here, and also on top of it, I have obviously I have attractors that are doing their own over here. I think also I have the yeah, attractors size effect. So you can see where when the attractors are close, the snake is becoming bigger. Okay. Um, yeah, I think this is it for this example. Let's go back to the viewer and choose the jellyfishes. All right, so they jellyfishes. If you like don't see anything and it's like lost, you can just press the panel and H, and it will home your camera. Cool. So this is the jellyfish simulation, which is also based on the ParticleV. So what I have here, so as you can see, most of the examples, the cluster, the brain, and the jellyfish are we're doing stuff with here with this part, which is feeding back. And I highly recommend you to just like experiment with like put in here tops like ramp. I won't show you now, but like you can do stuff. I don't know. Sometimes it's making some really crazy stuff. And I don't know, like convolve maybe, mate. Obviously, you can do like parts of the like with the mate. You can decide which part of the particles are manipulated by which texture. Um, I don't have time. I don't want to this tutorial to be longer than like 1 hour, which we're almost there. Um, so probably I will make more examples and like small tutorials about each example to show you how I do more stuff. And obviously, I will recommend you to just experiment um, and see what results you're getting. So this is like a very cool example of experimenting with the system, and just like it suddenly happened and I was like, whoa, this looks like a jellyfish. So yeah, I didn't plan it, but I think this is like the fun of playing with this system because it's like really unpredictable. So for this I'm using a pixelate. So let's do it step by step. So I'm using a pixelate. All right. Obviously there's a force, a noise force. And about the color, it's like just a light, two light. Where is the render? So I have two lights over here. Each of them is like a different color. So yeah, this is for the color. Um, so this is like the pixelate, and then so it's kind of creating the head of the the jellyfishes. And then we have a slit skin, okay, which is David Brown's slit scan. You can find it in his GitHub. Just search for David Brown TouchDesigner shared folder. So very thank you so much, David Brown. This is like a really, really great folder that he shared with a lot of stuff. So I have it here in the palette. Um, yeah, Designer shared, and there's a lot of stuff over here that you can use for a variety of stuff or reasons. So the slit skin is basically making those trails, all right? So you can see uh, what's happening, and you can make the trail longer by making the cache size longer. Um, and Also you can play with the bounds here, the X bounds, or like create your own slit scan. But these values are during those jellyfishes, and a dumper is just because it's like a dumper. It's also David Brown's component. It's basically damping the velocity, so you can see it's like damping it, but it's also making the trail um, like smaller. Um, but yeah, it's also a thing to have. Um, and a rotation, I'm just like rotating all of them in the z-axis. So it's like, yeah, cool. Um, what else I can show you here is right. So let's on the same for the color. So if I remove the uh, like let's keep one light for a second. If I want to color them, so this is, yeah, so if I want to like color them, I don't know, what is this? Let's make the noise like this. Um, Wait, let me go inside the inside the render so I can show you better. Okay, so as you can see now, the coloring is also from the pixelate, which is matches the pixelate over here. Um, and But it's not really matching because I'm multiplying the horizontal pixel size by 2, and this is creating the effect that the head of the jellyfish has one color and the rest of it, like the trail, has different color. If we want them to be fully one color, so it's multiplied by 3, and then you have like you know, each of them is one color. And if you don't multiply, they will have 3 colors each, and so on. So you can play around with this. Um, cool. So yeah, as you can see, um, yeah, there's a lot of stuff you can do. I hope I explained everything, and obviously, if you have any questions and if something doesn't work for you or there's any bugs, obviously, I've developed this component, and probably you will face maybe bugs of like different versions of TouchDesigner or stuff like this. So don't hesitate and tell me that you have a problem, and I will try to fix it. And Yeah, I'm really excited about this. Please, if you use it, make sure that you're tagging me or tagging ParticleV. Um, and I hope you will like it and you will get used to it slowly. And please, again, don't hesitate to ask questions. And I uh, um, I think I will do more examples in the future, so you will have more variety of examples to start with. So thank you so much for your time and for watching, and I hope I will see you soon again. Bye bye.